the practice based on. Now we will do the practice based on common collector and common drain amplifier. So hardly we have 4 problems I observed. 2 questions I have seen from BJT chapter and 2 questions are from MOSFET. Hardly 4 questions. We can do it. Before that, we'll make a short notes first. What are the formulas we'll recollect, and attacking these problems will be easier for you. So common collector don't take much pain, and common drain they'll take less number of questions per. How the questions will be, now we'll have a practice now. Okay. So maybe this video will be very short, maybe half an hour, 40 minutes video it is. After this, we'll take just 5 minutes break. After that, we'll start a new video again called common base and common gate theory analysis. We'll study. After that, again we'll have a small break. Then we'll go to the workbook practice. Okay. Like that, we're completing the task. So anyway, I'm expecting. Please note on this question numbers. We'll write a short notes based on this. I'm expecting all the students came back. Okay. Just to give some indication in the message that you came back. Yeah, Samresh, yesterday remaining problems in common emitter between the afternoon session. Okay, at least if you can complete morning session, common base amplifier techniques and problems also. Afternoon we'll cover the common emitter extra problems and MOSFET problems. Okay. पूरा आज ही खत्म हो जाएगा, don't worry. Today we'll finish all the problems. So that all the questions will be there with you. By 4:30 we'll try to target the complete problems. First concept, common collector, complete charge. So yeah. So please note on this one. I'm just following the electrical book for these 2 chapters, chapter 5 and chapter 7. You just follow this book. Question number 14, question number 22 in electrical book, and chapter number 7, question 4 and T1 is a common drain amplifier. So let us start. Let us start a short notes. A simple short notes, you can see. Simple short notes. First is a common collector amplifier. First is common collector amplifier. So roughly if you draw the model without any biasing, if you show like this model, in a simplified manner you can show. This is RE. This is RE. We're taking some output here. This is your input. And short to VCC. This is a common collector amplifier. How to recollect the analysis try to see. Here, from here to here, we'll have some R pi, is my idea. We'll have some R pi here. If I ask you from the base, what is the input impedance? From the base, if I ask you, what is the input impedance from the base? Then your answer should be ZB input impedance is equal to R pi plus 1 plus beta times of RE. So straightforward, you must get the answer like this. Seeing from the base, this is the answer. R pi plus 1 plus beta times of RE. Seeing this is emitter point. Seeing from the emitter, what is the output impedance? Z0 is equal to, it is RE parallel to, inside of emitter, what will be there is 1 by GM. Simplified answer you can write 1 by GM. So RE parallel to 1 by GM. What is the gain? It's a buffer. The formula will be GM into RE divided by 1 plus GM into RE. This is called buffer formula. This is called buffer. And what is the current gain we got here is, current gain formula is beta into RB by, if you have RB, RB will come RB plus your ZB. So this is the current gain formula. So this completes your total 4 parameters, observations. Seeing the board, you can write this answer straightforward. This also you can write straightforward. And this answer is a buffer technique formula. This is the only formula you just recollect from the common emitter and bypass. So this is about common collector analysis. So to do the problems, this much knowledge is enough to do the questions. So this is about first one. Coming to the common drain amplifier. Common drain amplifier. This is RS. You're taking the output V0. This is VDD. And this is your input. Your input, this V0. So this is the second model. In this case, I think we have open here. We have open from the gate point. We have open here at the gate point. So what is the input impedance from the gate? So I want to ask you input impedance from the gate. From the gate means G. It is infinite. We will get infinite from the gate point. And what is the output impedance here from the source? Z0 is equal to RS parallel to 1 by GM. So what is the gain here? What is gain? It is nothing but GM into RS by 1 plus GM into RS. So these are the 3 formulas we have to practice. This is one formula. This is one formula. This is one formula. So here I will write common collector and common drain amplifiers are used to solve loading effect. To solve loading effect, that is input impedance should be high. This is one point. Second one, to solve impedance matching problem. Impedance matching problem. Where we need output impedance should be low. Your output impedance should be low for it. Impedance matching, output impedance should be low. So these 2 purposes we use our common collector and common drain amplifiers. So this is the short notes for you. So this completes the total behavior what we studied till now. Okay. So Anupam Das थोड़ा what you have to do it here. Either I have not seen electrical and EC दोनों नहीं देखा. Only electrical book देखकर कर रहा हूँ. Just वही questions will have somewhere in your EC book. Afterwards you can search the questions. Okay. Any one book is enough to do it. If you do it one book means the remaining questions maybe in some other order will be there in EC book. So don't expect from me. You just try to think from where the questions. And the board when I'm writing the diagram you can search in the EC book and just notify the question. Okay. Unnecessarily this book and that book दोनों देखकर time waste हो रहे. That's why one book I'm solving first. So please take down. We'll finish the problems based on 4 questions are there. The questions from the EC book you can pick whenever you see that circuit from where it is coming. Anupam Das I have mentioned here. Chapter 5 electrical book. Chapter 7 electrical book I have mentioned it. Then why you are getting confusion? I have just mentioned there here. It's not EC electrical I have written. Triple I have written here. From the triple book I have taken these question numbers. Okay. So I've taken from Triply Anupam Das. So please complete it. Let's start completing that 4 questions related to common collector and common drain amplifier. The first question, can you read the question number 14 in electrical book? Question number 14. Try to observe the question. What he's asking, try to understand it. 14th question is a very interesting question he's asking. What he's asking, try to understand. It's related to a common collector amplifier he's asking. It is related to a common collector amplifier. So before I am teaching, you try to solve the questions. Shamnidas, this is only a rough analysis I'm doing. If you have some RG here, you just take parallel to infinite. In this problem, short notes, we don't want to include capacitors, we don't want to include biasings. The only rough idea is inside what is there, I'm finding first. Remaining things when you contact, it will come parallel to that. No need of studying that many number of times at that point. Okay? Who will get this knowledge? Inside impedance, outside impedances, all these things. It's easy to write parallel combinations. So it is not required to show in short notes. If RG is there, you take parallel, nothing to do extras. I'm talking here from the gate, what is my input impedance I'm teaching. Okay? Not from the circuit, from the gate I'm teaching. So let us start the electrical first questions. So it is based on chapter 5 we are teaching. Chapter 5. We have 2 questions now. Question number 14 identified. Question number 22. In single slide, I complete these 2 questions. Question 14, if you observe, question 14, he has given a common collector circuit. By seeing this, you can identify this is a common collector. This is why he has given a common collector amplifier. And he said that which one of the following conditions ensures a constant small signal voltage gain for a wide range of RE. He is expecting a constant, last statement you can read, constant small signal voltage gain he want. Small signal voltage gain. Is expecting a constant small signal voltage gain for a wide range of RE. For a wide range of RE. Then what is the condition should be satisfied? He's asking first of all, constant small signal voltage gain. What do you mean by small signal constant means? Maybe there are some variations in your gain. So which factors can disturb your gain? First try to understand. You already know the voltage gain of this amplifier. First try to write that amplifier gain. So analysis I'm doing from here. First to write the gain formula. Why it is not constant? First we'll understand it. The gain formula is, it is a GM into RE divided by 1 plus GM into RE. Actually this is the gain formula, correct? So you can write this answer as simply RE by this GM, if it bring bottom side, it becomes 1 by GM plus RE. You can also write like this formula. So gain formula, we can write it as RE by RE plus RE. The same gain formula we can convert like this type. Okay? So in this total, this capital R is a fixed resistor because it's a lab resistor. In the labs, whatever the resistor you take, it never depends on temperature, it never depends on fluctuations, nothing. RE is constant exactly. RE, capital RE is a fixed value or a constant value. It's a constant resistor. So it's a constant. But I have doubt on small RE. Small RE is called as a dynamic resistance. It dynamically varies. Dynamic resistance changes by temperature. So this is the notification I have done. So this gain is stable with RE, but with not small RE, because small RE depends on temperature. So temperature if it changes, small RE will change. Then it is unstable. But he's asking you to make it a constant small signal voltage gain for a wide range of RE, how to take the condition. So you can write this answer. AV is equal to 1 by 1 plus RE by capital RE you can write. Correct? You want gain 1 to become 1 suppose. It should be a constant 1. This quantity should be neglected in the class. RE by RE should be neglected. This is a constant value, but this is changing with respect to temperature. So what I'll do is, AV, we can write it as 1 by 1 plus RE means is nothing but VT by ICQ into RE. So this RE is nothing but VT divided by ICQ. Okay? Then you can take here ICQ operating current into RE, who will take much greater than VT. Then the gain becomes 1, which is a stable gain. Which is a constant gain or a stable gain. So like this you can make the gain, stable gain in electronics. So I'm expecting this is the way how a gate examiner is asking question for. So a gain of a common collector is not stable with respect to small RE. It is stable with respect to capital RE. If you want to make a good stable system, what you have to do is this answer ICQ into RE. You have to dominate the volt equivalent temperature because in volt equivalent temperature we have temperature T. T by 11,600 is VT. So if you neglect this term with respect to this term, I think answer will come 1 so that the gain becomes constant value. So that is a beautiful question he's asking. Gate 2014 is asking this question. So I'm expecting IC into RE should be much greater than VT is correct. So option B you can take it as an answer. Option B is a right answer for it. Okay? Option B is correct. Are you agreeing with this point? Option B is correct answer for this. Next come to the 22nd question, we'll wait. One more question is question number 22. I'll finish in this slide only, question number 22 also. Question number 22, if I do here, he has given here Vs, next to capacitor, next we have RB, next to transistor, 10 kilo ohms, 40 kilo ohms, 40 kilo ohms, this is the output, base is C, beta is 200. This is the question we are seeing. Okay? He's asking this question, the input resistance from the base. Correctly if you observe, the question is asking from the base, means this is your base. So he's asking the input impedance from the base, means ZB is asking, which we practice in your short notes. From ZB, what is the input impedance is asking. That is the reason in the exam they are not given this value, because it's not required. Because RB after that we have the base. So, yeah, further Sardi, we can do like that also, that is your wish. OB sahi hai. GM into RE should be much greater than 1. OB sahi hai. Just I'm showing technically the meaning of the subject in formula wise. Okay? You can RE is a dynamic resistance, it depends on temperature. Maybe this is disturbing the gain. So with the help of it, we can write the condition. That's not a problem. Fundamentals, you must be strong to write this answer. Now can I say ZB? What is the answer here? If I want to know ZB, first can I write the AC model for this? Correctly say this AC model I'm writing. This is Vs. Next to capacitor short, we have RB. Next to transistor will be there with the 10 kilo ohms. VCC B is ground. Next to 40 kilo ohms. This is your output. And VCC is ground. Can you see the AC model I have written? This AC model I have written. AC model is nothing but capacitor should be short. DC should be grounded. I have done nothing more than that. AC model first you complete it. After completing the AC model is asking you the base side, what is the ZB input impedance? We have already a practice on this. ZB formula we have studied is, it is R pi plus 1 plus beta times of RE we have studied. This is the formula we have studied. R pi plus 1 plus beta times of RE. But in the question, has it given R pi or not? You have to see in the problem. In the question, I think VCC itself is given unknown. When there is no VCC, we cannot find beta RE. If R pi is not given, at least beta RE we can solve. But biasing also not given VCC. If VCC is not given, your R pi can be neglected in the problem. Neglected because VCC not given. If VCC is not given, how you can solve R pi, which is beta RE? Operating current you cannot solve. That's why intelligent people will have to think like this. If VCC is not given means he is not interested with R pi. So R pi को छोड़ दीजिए. Okay? If they don't give anything, छोड़ दीजिए. Then what is the answer is simply this total combination, whatever you see, now this will become your RE. Previously RE means only 10K. Now what happened is one more load he connected parallel, so the total net effect will become RE. So the answer will be ZB is equal to 1 plus beta times of RE. It will become 1 plus beta times of RE means here 10K parallel to 40K will be the answer. Some students will write only 10K, some students will write 40K. ऐसे नहीं करना यार. You can connect number of loads like this. Coupling capacity पूरा load आपका RE हो जाएगा. 10K parallel to 40K will be the load value for you. Okay. If suppose 40K is not given, only 10K will become your RE resistance. So I think you can face this problem. Beta is given 200 into 10K parallel to 40K. So please solve this one. ZB how much? ZB will be the how much? Base resistance. It will come in mega ohms I think. Solve it. How much is coming? शबरीदास आप क्यों बोल जा रहे हैं always subject में अब इतनी बार teach किया मैं R pi can also be called beta RE. I said or not? R pi is always equals to beta RE. R pi not given हम क्या करना beta RE को solve करना. But beta RE क्या है? VD by ICQ. ICQ किधर से आते हैं आपको? DC सप्लाई से आते हैं ना? VCC biasing से आते हैं. He has not given biasing. VCC not given. If VCC not given, then common sense use करो. ये कैसे solve करते हैं आप? So that has to go into your mind first. वो inject हो जाना mind में. Okay. When VCC not given, SAR is neglecting R pi because beta RE it is. But RE is depending on operating current. VCC not given, how operating current we can solve? Like that examiners will play a role with the students. आपका mind को confuse करने के लिए पूरा stories. So let us have a story. We can pick it the story in your mind. Okay. R pi if they give directly you can take. R pi नहीं देते. We have indirect chances beta RE. But beta RE here. ICQ come from VCC. So this is the background story for that. Why VCC is neglected? Then R pi why we are neglecting is this can be neglected. We can neglect it. So how much ZB is coming? Surya Pratap 1.6 mega ohms. Great. 1.6 mega ohms will be the answer. 1.6 mega ohms. Correct. Great here. Good answer. 1.6 mega ohms. So this must be the way of doing problems. So you can see how the questions they are asking the subject. So they are not very tough here. Very easy to do these problems. So common collector ज़्यादा time waste नहीं करना. Simple designs easily you can complete. So we'll see common drain problems how they are asking. I'm going to the next slide. There are two more questions I complete. With that this job will be completed. So please complete it. We'll come to MOSFET problems. Can you do it question number 4 by yourself? In chapter number 7, question number 4. Try to start doing it. You have the knowledge. Short notes is there with you. Everything is there. Without my help, you can solve these questions. But you will take my help. I know that. That's why I'm doing step by step. So please do that problem. Question number 4. Chapter number 7 we are doing. Chapter number 7. Question number 4 and a T1 question. These two questions try to develop it. If you see question number 4, he has given coupling capacitor, transistor. There is RS here. This is output. This is VDD. This is your VS. This is the circuit we are seeing. It's a common collector circuit. In this given data is GM he has given directly. So 3 into 10 power minus 3. GM already given. RS is given. That is 3000 ohms. He is asking you, can you calculate the output resistance? It's a very easy question. From the source is asking output resistance. We have the trick here. What is the formula for it? From the source, whenever you see from the accurate concept, RS will be there. Inside will be 1 by GM will be there from the source. From emitter it is 1 by RS. Okay. So it is RS parallel to 1 by GM. So this is output impedance problem. So in the workbook I think we are covering all the problems. Input impedance I covered. Now output impedance we are covering. And one is gain problems we are covering. All issues are covered in this practice. So RS is given as 3000 ohms parallel to 1 by GM. This is 3 into 10 power minus 3. So make it a parallel combination. You will get the answer for it. Akash Mitra already given answer. Very good. 300 ohms is correct. Great here. Akash, good answer. 300 ohms is the correct answer. Great. Perfect answer. And somebody Aditya is telling is facing problem in login. Okay, you send that number. The technical team will take care about it. Aditya, just they'll note your number and they'll message for you. Don't worry. And if you have that medicine number also, please call to the technical team also and try to resolve it. Because I cannot resolve it, but I can send you this message to the people. Okay? 300 ohms is the correct answer for it. 7 MOSFET questions. Electrical only this book I am doing. And coming to the last question that we have is, one beautiful question is asking T1 question. Next question we have is T1 question. See the interesting point here, T1 question. He has given here signal VIN, capacitor and resistor here RG, which is 50 kilo ohms. And we have a MOSFET with a current IDQ, the battery of minus 5 volts, having a load as 4 kilo ohms. This is your output, and we have 5 volts. You can see this is the circuit given T1. Okay, it's a common drain amplifier because you are taking output from source. To take the output from the source, we can call it as a common drain amplifier. Okay, it's a common drain amplifier. Prashant Kumar, these questions are not there in EC book. You just practice in electrical book. Okay, if they are not there, you practice here. So right, T1 question. Definitely will be there. I'm expecting these questions will be there. Just I'll identify afterwards. So T1 question, what he has given is that the gain is 0.95. This is a given data. Gain already given by him 0.95. And threshold voltage is 1 volt. VT means threshold voltage. And half into nu n Cox. Half into nu n Cox is given as 30 microampere per volt square. This is the value. So neglect channel length modulation effect. Lambda is at 0. Neglect the channel length modulation effect. So IDQ, operating current IDQ has given straightforward in the problem. DC operating current is 4 milliamps. And he's asking you W by L, can you solve? This is the question actually. The complete data he has given. Yeah, definitely will be there. EC book में अब identification करके करो. So W by L you have to solve. But one thing here, he has not given VGSQ, he has given IDQ in the problem. So we should have a talent. How GM we found in the previous notes is with respect to VGSQ I found. But how to convert that into IDQ formulas is important. Let us see a small formula practice will do it. GM formulas how to practice. GM formulas how to practice. So I started here analysis. Your ID formula we know is half into nu n into Cox W by L VGS minus VT whole square. This is the current saturation equation we have. This is current saturation equation, correct? Then if I want a GM, I said that GM is nothing but just you have to make x square, derivative 2x will be there. So derivative of ID by derivative of VGS, if you do it, it is 2 into half into nu n Cox W by L into VGS minus VT. So 2 will be cancelled. So this is the way GM is coming. GM is coming like this. Okay, but here GM formula we know in the class with respect to VGSQ we know. Like this. We know VGSQ, but in the question he has not given VGSQ, he has given IDQ. Then how to convert VGSQ form to IDQ form? Just you have to do it some more mathematics. What I'll do is this VGSQ minus VT whole square. VGSQ minus VT if I want to throw there, then you can write it as ID by this term will come this side. Okay, this term go denominator will over. Then what happens? VGSQ minus VT can be written as ID into 2ID by nu n Cox W by L under root it will become. So this formula have been replaced. VGSQ minus VT if you don't want, we just replace it by square root terms of 2 will go that side, 2ID by nu n Cox W by L. We just do some mathematics like this and convert the formula into ID form to do these problems. Okay. Sumanta he said this is an amplifier with a gain. Whenever the person said it's an amplifier with a gain, automatically it will work in current saturation. It is not required to test it. When you say that there is a voltage gain given already in the problem. Not only that, operating current also he fixed it. Generally where we fix operating currents only in current saturation. So straightforward you can say. Okay, nothing to test it. So if you substitute here this formula, GM is equal to nu n Cox W by L into under root of 2ID by nu n Cox W by L. So you do some mathematics like this. So that the formula will be written now with ID form as under root of 2ID cube operating current into nu n Cox W by L. This is another way of writing GM formulas. GM, anybody want to solve in terms of IDQ, just you do some mathematics like this and convert into this form. So this is a GM form with respect to IDQ. So one time if you know that formula, I think doing the problem is simple. So formula, if you know that, I think the gain formula will apply to solve this question. Okay, we'll apply the gain formula. We'll apply the gain formula. Gain formula for this is GM into RS divided by 1 plus GM into RS. Okay, here RS means here RS becomes RL. This 2 will be same. So GM, JAB is given 0.95, gain is already given. GM formula you apply root over 2 IDQ nu n Cox W by L into RS you take it as RL which is 4 kilo ohms divided by 1 plus under root of 2 IDQ nu n Cox W by L into RS into 4 kilo. If you say correctly, I have been applied the total concept. So gain formula is total values are applied. The only unknown term in this problem is this one. This is unknown. Everything is given in the problem. So W by L is unknown. You can solve this problem with this approach. So I think you have to find out this equation and say what is W by L. You just throw the calculations and see how much the answer is coming for W by L. So this is the way how can I solve this type of questions. Just formula based questions there. GM we have got a new style of formula with IDQ technique. So just solve this one. With this we'll close the practice session on common collector and common drain practice is completed. After this just 5 minutes, just 2 minutes if you wait, we'll go for new video now. Okay? New video we'll try to start. That is called theory part 1, common base and common gate. That is the final analysis. By 1 o'clock or 1:15 or 1:30, we'll finish the total story of this, and finally we'll enter into the workbook practice of previous module called common emitter and common source. What are the remaining problems we'll try to finish off. Okay, that is the job today. So 47, some student has given the answer. You can also verify the answer whether it is 47 or not. I think most of the students are getting 47. Great. So we'll take confirmation that 47 will be the WL ratio for us. So with this we have been completed the concept. We have completed the concept. So these are the questions we have to solve in the practice of common collector and common drain amplifiers. Okay. So please note on it. So I hope you got confidence on this common collector and common drain. Let us finish the final technique. Let us finish the final technique that is called common gate and common base amplifiers. How to analyze it? That is the final issue. Okay. So please complete up to here. So can I expect these are all clear for you? Questions? So that I can start a new module, that is last module. Common base and common gate will try to work out the final answers.